So 2.2 expands on what we did in 2.1 with functions, but now we're dealing with linear relations and functions. So an equation such as x plus y is equal to 5 is called a linear equation. This is in standard form, which we'll go more into that on a slide in a couple pages. But not all functions are linear functions. So a linear equation has no operations other than addition, subtraction, and multiplication of a variable by a constant. So we can't have division, although we can be multiplying by a fraction. So if we look in our examples for linear equations, we see here that we're multiplying by a fraction. So it may look like division, but it's still multiplication because we're just multiplying by a fraction. The variables may not be multiplied together or appear in a denominator. So an example of this one would be an x times y. This would be nonlinear. So here are nonlinear options. We have x times y, and then x is in the denominator here, so these are not linear functions. So we can't have two variables being multiplied together or in the denominator. A linear equation does not contain variables with exponents other than 1. So we cannot have a y squared, and we also can't have the square root of our x or y. And then the last point here is the graph of a linear equation is always a line. So all of these equations, if we were to graph them, they will always be a line. These nonlinear equations are not a line. So in the second one here, even though we don't have a y in this equation, we still have x is equal to 10, and nothing crazy is happening to that x. It's not being squared, it's not being multiplied by anything, it's not in the denominator, so it would still be a linear equation. A linear function can be written in the form f of x is equal to mx plus b, where m and b are real numbers. Remember that f of x is just a fancy way of saying y. So this is y is equal to mx plus b. And you guys have all seen this equation before. This is your slope-intercept form of a line. So we know this m is our slope, and this b is our y-intercept. Which this form, having your equation in this form, will help when we start to graph, but we're not going to graph today. All right, here we have some examples. State whether each function is a linear function, write yes or no, and explain. So looking at the first one here, let's call it a. Do we think it's a linear function or not linear?
Not linear.
Why do you think it's non-linear?
Wait, never mind.
So do you think it's linear or non-linear?
Linear.
It's linear. So f of x, remember, it's just a fancy way of saying y. So we have a y and an x. The only thing that's happening here is multiplication and subtraction. So this would be linear. All right, so because it's blurry for you guys, I'll read it, but we're moving on to the one in the middle on the top. So we have f of x is equal to 2 over x. So let's call this b. Is this linear or non-linear?
Linear?
Are we allowed to have an x in the denominator?
I don't know.
Go back to the slide before.
No.
Nope, we can't have an x in the denominator, so this is non-linear.
Can you explain, like, if it's linear and non-linear, what are the rules again? I'm sorry, I couldn't understand the first time.
All right, let's look at C. So the one on the right on the top for you guys. So would this be linear or non-linear?
Non-linear.
Non-linear, awesome, because we can't have an x in the denominator, so this is non-linear. All right, let's go to the bottom left one. We'll call this D. Is this linear or nonlinear? What do you think, linear or nonlinear?
Linear?
Are we allowed to have an x times y?
Non-linear.
It's nonlinear because we can't have the x times y. So since this is x times y, this cannot happen. So this is nonlinear. All right, and the last one, linear or nonlinear?
Linear.
It's linear. Nothing super special is happening to it. We have some fractions in here, but that's fine. So this is linear. Okay, any questions from this page? So it told us to write yes or no, so I'm just going to go back and say yes, no, 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 and yes. All right, no questions? Ready for the next page? All right, so this is standard form of a linear equation. So we have our constants, which are a, b, and c. So there'll be some type of numbers. And then our variables are x and y. The only variables we'll have here are going to be an x and a y. And then it has to be in this order. So you have to put x first, then y, then equals, and then some constant. So if we had 4x plus 5y is equal to 6, this would be in standard form. If we had 6 plus x is equal to 2y, would this be in standard form?
No.
No. How would we get this into standard form?
Turn the 6, give the 6 a y and multiply it by y. And switch x with 6y, or would it still be the same?
We can't multiply, so we can't change the y to be with the 6, but we can subtract 6 on both sides to move the 6 over to the right side. So remember, we're doing the inverse, and then we can subtract 2y on both sides. So we're doing the inverse to get it to move to the other side of the equal sign. So here we have x minus 2y is equal to negative 6. So then this would be in standard form. So all I did was move some things around in our equation. If we move it from one side of the equal sign to the other, we have to do the inverse operation. So here, since this was a positive 2y, we subtracted 2y to get it to the other side. And we had a positive 6, we had to subtract 6 to get it to the other side.
Wait, Miss Carver?
Yep.
I thought we can't, if the variables aren't the same, we can't, subtract or add it.
We're not combining them. We just leave it as x minus 2y. So that's good. They're not like terms, so we can't combine them. But we can still move the 2y to the other side, but we just can't put them together. So we just have x minus 2y, and we have to leave it like that. So the 6, all we're doing is moving it to the other side, so we subtract 6 on both sides. So we're not combining the 6 with the 2y, we just move it to the right side of the equation. So we just subtracted 6 on both sides, so it canceled out on the left, and then we were just left with the minus 6 on the right side. So we're not combining it with anything. It doesn't have any like terms that we could combine it with, we just need to move it over. All right, here we have our last slide. So we need to write each equation in standard form and identify A, B, and C. So we know that A goes with our x, B goes with our y, and c is our constant. So for our first equation, what do we need to do to get this into standard form?
Add 9.
Add 9 to both sides. So it's going to cancel out on the left side of our equation, and we're going to be left with 3x minus 6y is equal to 9. So now, perfect, this is in standard form. And what's our a, b, and c? What's our a?
3.
Awesome. What's our b?
6.
Our b would be negative 6 since it's minus 6. So our b is negative 6. And then what's our c?
9.
9. So here we have our standard form, and then our a, b, and c.
Do we have to put the A, B, and C?
This is asking us to, and the homework also will ask you to identify a, b, and c. So yes. All right, let's look at our second example. So what do we need to do to get this into standard form?
Subtract 8y.
Awesome, we subtract 8y on both sides, so it'll cancel out on the right side. And now we have negative 3 over 10x minus 8y is equal to negative 15. Is this in standard form?
Yes.
Yes. Perfect. So now we just need to identify our a, b, and c. What is our a?
Negative 3 over 10.
Awesome. Negative 3 over 10. What's our b?
Negative 8.
Negative 8. And what's our c?
Negative 15.
Negative 15. Perfect.